we're here with Paul Hoffman to talk about Snowball Earth and the snowball effect. Paul, could you describe your research focus and your current position?
Yeah, well, currently I'm enjoying retirement, the most productive time of my life. And I've just finished a textbook on called Snowball Earth in 4G. And the 4Gs are geology, geophysics, geochemistry, and geobiology. Okay, and so you have to combine these four disciplines together, as different as they are, both in the way they approach problems and the way they think about problems.
Could you tell us a bit about your book on the snowball effect?
Yeah. Well, the book begins with modern glaciers and ice sheets and sea ice and ice shelves and the processes of glacial movement and erosion and transport of sediment. Then it looks at the history of glaciations of ice ages over geologic time. Then it poses the climatological problem of low-latitude glaciation at sea level, which occurred twice towards the end of Precambrian time, and the possibility that this could be explained by this white Earth disaster, as it was called, among climate scientists, and the story of how it became apparent that this was self-reversible, this white Earth disaster, and how that made it geologically possible. And the high point of the book will be the first really cogent, I think, explanation of the response of the biosphere to a period in geologic time when the oceans were completely dark for tens of millions of years.
What made you decide to research the snowball effect, and how did that shape your career?
I had an old friend at Caltech named Joe Kershvink, and he was a paleomagnetist. That's a person who studies the remnant magnetization in rocks, from which you can tell the latitude that the rocks, that the remnant magnetization was formed in. The third Congress I went to, which is the one in Washington, D.C. In 1989. And at that Congress, I was, it was in the middle of a heat wave, and I was standing in line waiting for a bus, and who should I see but my old friend Joe Kershvink. Because I'd been at Caltech back in the mid-'70s, and he told me about Snowball Earth. While we were waiting in line, at 110-degree temperature.
Could you describe some of your most significant achievements of your career?
Been the one who really was the prime advocate for Snowball Earth and took the hypothesis seriously as a testable hypothesis that should be tested, because the ramifications, if it was true, were profound, particularly in terms of the response of the biosphere, which has ramifications for the nature of the biosphere.
Any geological evidence of the Snowball Earth hypothesis here in Canada?
Yes, there are wonderful deposits of that age of both the snowball events in the Mackenzie Mountains in the Northwest Territories and in the Ogilvie Mountains in central Yukon. And they've played an extremely important role, particularly in the testing of Snowball Earth.
Just to close up our conversation, why should the international geoscience community want to come to Canada in 2028?
Well, I have three reasons that are independent of the program. And the first one, field trips. The second is the personal contacts that you make at a conference. So the personal connections, that's the second thing. And then the third example is the ideas that you pick up just from informal discussions you have with people.
Thank you so much for sitting down and talking about Snowball Earth. It was interesting, very, very fascinating. Thank you so much. As we tackle climate challenges, learning from Earth's past is crucial. Professor Hoffman's work, honored with the Kyoto Prize, underscores the need for ongoing scientific exploration and environmental protection. We look forward to hosting the International Geosciences Congress in Calgary in 2028, using the city's geological legacy to encourage worldwide cooperation and creativity. Join us in shaping the future of our planet.